Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Cislunar Industries is a company focused on metal processing within the space industry. Their vision centers around enabling humanity to expand beyond Earth and settle the solar system sustainably. To achieve this, they develop and operate space foundries, creating critical metal materials for use in space and on celestial bodies. My guest on this edition of the Ex Terra Podcast is Joe Pawelski, co-founder and CTO of Cislunar Industries. Joe, welcome to the program.
Hi, it's a pleasure to be here.
Let's start out, first of all, with some congratulations that are in order because Cislunar Industries recently flew into space. Give us a recap.
Sure. We flew our first high-power electronics. It was a high-voltage power supply, and we did that as part of a payload that ThinkOrbital flew as part of an e-beam welding experiment. As far as I know, it's the first automated e-beam welding experiment that's ever flown into space. And it's the first time anything's flown on, I believe it flew on a Falcon 9 first stage. So you can get with ThinkOrbital for more details on that. But we were really pleased to help them out on the high voltage electronics that were part of that. And that's a big part of our business that maybe some folks aren't aware of. But we like to make arcs and sparks. And turns out a lot of other people have a hard time making arcs and sparks. Usually you try to avoid that. So.
And it sounds like arcs and sparks may be something that's very necessary when you start talking about doing things in space.
Exactly. All of a sudden, again, most electronics engineers try to avoid that. But suddenly you want to do welding, or you want to do plasma propulsion, or you want to do regolith extraction. There's all kinds of reasons why you might want to make arcs and sparks in space.
Tell me about this e-beam technology. What is it, and how would you describe it?
Well, again, the e-beam technology was developed by ThinkOrbital, and e-beam technology it's been around for quite a while. So I'm not an expert in that. I can tell you a little bit about it, but one of the advantages of e-beams is you can have a very directed energy. So this is great for making very precise welds. It's also great for making cuts and things like that. There's e-beam machining. So in space, the name of the game is we don't want to create more particles, or we don't want to create more debris. I mean, that's the whole idea, is we're trying to prevent debris. So manufacturing processes that don't make debris and that don't require that aren't very invasive are really interesting to us. So that's how we got involved with ThinkOrbital in the first place. Is you can think of us as the steel companies and the industrial hardware for space, if you will. Right. So this idea of e-beam welder is something that we've needed a way to cut things, to cut up space debris, and to aid with manufacturing for all the things that we eventually build. So e-beam is one of the really interesting technologies. Now, laser is another way that you can weld and cut. Now, there's advantages to lasers as well. Lasers operated in a vacuum can have penetration in welds, unlike e-beam, but there's pros and cons to each. So all these types of technologies are interesting. And I also mentioned the last one. I don't want to get too far ahead here, but nanoracks, and then of course the way a lot of aluminum tanks are made is with spin cutting and friction spin welding.
Okay.
So that's another way that you can cut metal and weld metal without producing chips and things like that.
Well, let's come back to your company and talk about that. Didn't mean to get off track there, but what Joe inspired Cislunar Industries to focus on metal processing and specifically for space applications?
So we looked at what are kind of the industrial foundations that allow these economies to expand.
Sure.
And we looked back to, during the Industrial Revolution, steel was kind of the ticket that really made industrial growth happen. So one of the things you look at is the railroad, the Transcontinental Railroad. Before the Transcontinental Railroad, it was very hard to have industrialization grow across the country. And then once there was a railroad there, and all of a sudden all these resources were available, and that whole economy and that ecosystem really started to prevail. So we think similar things are going to be required in space. The railroad in many ways is a logistics layer. That may be steel, it may be aluminum for spacecraft. It may be platforms to supply these and provide like a yellow brick road, if you will, from here
Sure.
to the Cislunar, through Cislunar space. But that was really the inspiration. The other part of it was, we need power. So I was really intrigued by solar power beaming and these sorts of things. What are the big problems that we could solve using space resources? And an abundance of space resources. And so early on, in the way I got involved with Cislunar was I noted, well, if we wanted to build these, Dyson spheres and these mega structures, these power beaming systems, well, we're probably going to need to get our resources from somewhere else. And so that's where the concept of using aluminum and other materials from the moon came from, was to actually provide materials for power beaming, things like that.
Let's talk about the Modular Space Foundry and the modular configurable electric power converter and the applications of those devices.
Sure. So the Space Foundry was really how this all got started. Okay. The idea was, okay, well, if we're going to use materials on the lunar surface, we could also use materials in space. And so we came up with this concept of a foundry that would work in both environments. It would work in microgravity, it would work on the lunar surface, and it would work for metals derived from regolith, and also metals derived from space debris, if you will. We call it resonant space objects, because that's a lot of things. And in some cases, you may have satellites that are end of life that are able to come over. And the con-ops for something that's already planning to come to you are a lot simpler than trying to grab something or trying to get small chips of space debris. So the Space Foundry is designed to work with both of those types of inputs in space or on orbit and on lunar surface. And in both places, what you don't have there is gravity, and you don't have maintenance people to come and replace things.
Right.
Excuse me. So the way that the Modular Space Foundry was conceived is that, we knew that without gravity, we needed a motive to push things in. Usually there's a big front end loader or something like that grabs things and then dumps into a big pit. Wouldn't that be, on the moon, those con-ups work a little bit better, but even still, with 1/6 gravity, that those con-ups don't work nearly as well. So we use an electromagnetic system to actually motivate, sort of replace gravity and motivate things through the foundry. And then we use that also to help manipulate the metal once it's molten. It's electromagnetic induction, so it actually melts the metal. That provides the furnace components. And then we use various other components to form it into billets and metal propellant. So what's cool about this, though, is that in developing that replacement for gravity, we developed this electromagnetic feed system, which relied on some really interesting electronics. And we developed what we call the modular configurable electric power converter. And this is a system of various bridges and various other components that we use to manipulate electrons. We use it to run the furnace. We use it to run our manipulator coils on our steer system, which pushes things into the furnace. And we also use it for electric propulsion, which is an interesting spinoff. So we've built some pretty high power electric power converters. Power management systems is really what these are technically referred to. But it turns out that taking power from a battery or solar plant panel, and then converting that power to AC or DC at a specific voltage, and then providing that to a thruster or a welding system or something like that. It's not a trivial thing. And you're also in space. So you have heat, thermal issues to contend with, and also, your reliability. Most of the time things break because it's some kind of a electrical power management failure, unfortunately. So anyway, we realized that, hey, we're pretty good at this. We flew some of these MSEPSIs, and we realized that throughout our ecosystem, a lot of our partners were like, wow, we'd really like something that's half the size, weight, and power, and twice the efficiency of what we have. So that turned into a very interesting commercial market that's been developing.
It sounds like that you're almost in the space recycling business, for lack of a better term. But when you do terrestrial recycling, they have to separate out all the different kinds of metals. And
Right.
if you're cutting up a satellite that has passed its useful life, how do you make the system differentiate between the different kinds of metals to then produce the stocks that you need?
Well, that's pretty interesting. And so our first SBIR that we won was for recycling space debris on orbit, which is pretty interesting.
Mhm.
And also we found out one of the uses for this space debris is metal propellant, which can be used for
Okay.
station keeping and various other purposes. So it's really debris developed to V, where it's a nice solution to the tragedy of the commons. But I do want to be clear that we got into this business of recycling space debris because it was an obvious feedstock for our foundries.
Mhm.
Uh, and in space, we realized, I think we're an industrial company, but we realize that sustainability and recycling things is one of the best ways to be successful here. Space is very hard to get mass on orbit. There's a big cost to it. So really, space debris becomes a resource, and that's how we got involved there. We also look at recycling on the lunar surface. There's going to be a lot of starships and other landers. And they're going to be made out of lots of really valuable materials. So it's a lot easier to derive those materials from lunar landers and things like this than to actually extract those from regolith in the beginning. Once we have economies of scale of power and we have extraction methods set up, then those economics will shift.
So, what applications can benefit from the metal feedstocks that are produced by the MSF?
Well, we make right now, Modular Space Foundry is making billets, and billets are very useful for pressing wire, other shapes. There's a number of there's a lot of research going on about using not great materials to produce pretty high quality engineered extrusions and things like that from aluminum. So that's a great near term structural use. The other opportunity is in metal propellant for vacuum arc thrusters. There's several companies that have produce these and produce thrust and sell these commercially. We've partnered with Neumann Space out of Australia because they have a really nice configuration that works well for something that we can cast. But this is an electronic propulsion system. It actually the technology is actually used for semiconductor fab. It's used for coating things in metal. Produces a metal arc. So we use that metal arc to produce meaningful thrust. And the thrust is actually equivalent to the ISP of roughly equivalent of a Krypton ISP. The energy efficiency is less. Now there is ongoing research and work that is improving the efficiencies, so your watts per Newton thrust. So that's pretty exciting future work. But right now, this metal propellant is extremely compelling for station keeping. We looked at stations that were similar in mass to ISS, and we realized that you could get by with 7 times less mass of propellant per year, which is huge difference. I mean, this
Sure.
is like an entire. I think they use thousands of kilograms of propellant to keep ISS on orbit. So, if you can reduce that, that's like an entire spacecraft. Anyway, and you think about other operations out in space where you're thinking of station keeping and things like that. Using metal is a really good option because it's also shelf stable, and then super compelling when you can use metal from stuff that would otherwise hit your spacecraft.
So then, what challenges did you encounter as you developed the Modular Space Foundry, and how did you overcome those?
Well, I'd tell you, and probably everyone will tell you that the biggest challenge is finding enough interest to keep these big ideas going over the course of technology development. Everyone talks about the valley of death, all these things, and that is very real. So the first way we solved that challenge was by developing our spinoffs. MSEPSI, for example, we've developed a number of commercial revenue streams for that commercial product to help throughout space, and that product has helped us identify a number of other revenue streams to make sure that we can get through that valley of death and that we're still here. So interestingly enough, the first one was not necessarily a technical challenge, but more of a business leadership challenge
Sure.
in operating in a dynamic funding market. Technically, though, a lot of the challenge are really in how do you prevent aluminum and other metals from freezing. And how do you prevent these metals from breaking the surfaces that they come in contact with? Because there's, they're usually very hot, so there's a lot of thermal stress on elements of the space foundry. So I would kind of narrow those down to gating, control of the metal, and just finding materials that are appropriate for these applications, which are very high stress applications. Beyond that, we're flying this to ISS next year. The safety review has been another challenge. So it's one thing to do this in the lab on the bench scale. It's another thing to do this in a human habited space, in outer space. So we just finished. One of the interesting tidbits I can share with you was we were going to use 6061 aluminum because this is very common. I mean, most of the space station is built out of that, interestingly enough, and other series of aluminum, but they're all relatively similar. There is some amount of lead in 6061. And that was just a non-starter. So they asked us to look into using pure aluminum. We said, okay, cool. We'll just use 1000 series aluminum that's pure, doesn't have lead in it. Well, even that, we had to get certified aluminum that it was a certain purity to make sure that there was no lead or other types of chemicals that could possibly get out into the human habitat. So, those are some other challenges that are just the I don't know if you put that in the category or the unknown category or the policy requirement category. But, those are some interesting things that we didn't expect to be challenges that were not specifically technical.
My guest is Joe Pawelski, co-founder and CTO of Cislunar Industries. Take a moment right now to click subscribe to be sure you don't miss any of our podcasts, or if you're watching on YouTube, any of the videos from Ex Terra, the Journal of Space Commerce. Joe, let's talk about you for just a minute. How did you get involved in the space industry? And then let's talk a little bit about the folks that you work with.
Sure. Well, I'm an OG, one of those original geeks that's been building stuff since I can remember. It started classically with the rocket set. My dad got me one day when I was probably 5 or 6, and I decided that I wasn't going to be a music man or whatever else I was into, that I was going to be a rocket scientist. And I never really changed that path. And so I could share all kinds of great pictures about things that I built as a kid. I was into Tesla things, so I got really into Nikola Tesla. I was also into games like StarCraft or Command and Conquer Red Alert, which are hierarchy type games, which is what systems engineering and space architecture truly are about. It's understanding hierarchy of all the different gaps in technologies that need to be developed. How to put all these pieces together. But what's interesting about that game is they had Tesla coils in that game as base defense, Red Alert, Command and Conquer. And that's really how I ended up, ironically, learning about Nikola Tesla. I was born in Richmond, Virginia, and there happened to be the Tesla coil builders of Richmond there, which were a bunch of computer science guys and Navy Research Lab geeks that would get together and build stuff that Tesla used to build. And then they ended up starting to build some of the first garage fusers and things like this. So at a very early age, though, when I was middle school, teenage, my dad would drive me there, and then I would drive throughout high school. I was exposed to all these, super geeks that were experimenting on the cutting edge of electronics. I was exposed to high temperature superconductors and what impedance and inductance and all these sorts of concepts were. And so that's kind of the spark that really drove it. And I ended up going to RIT, met a bunch of other engineering folks. And then interesting, and fluid mechanics is my background. So I was very interested in how all things work. And of course, electronics are not too different than we use a lot of the same equations as we do in fluid mechanics and electronics. So I'm not classically trained in electronics, but I end up spending a lot of my time in electronics, especially high power electronics. So, but a little bit non-traditional. When I got into my primary career, I spent some time working for a professor doing SBIRs and working for Department of Energy stuff. And classical internships at DuPont, and worked some on submarines. Interestingly enough, I had a TA who was on the same submarine that I helped build, the Jimmy Carter. It was a Seawolf submarine, which is do a whole other podcast about that. But I was going to get out of school. I was going to go work for Lockheed or for Boeing, and they weren't hiring. This was 2007. As a lot of people know, there was a little recession that happened shortly after. And I stumbled into high-speed manufacturing. A lot of things I would do is would actually engineer conveyors that were half a mile long or quarter mile long. I invented a high-speed industrial positioning system that utilized pneumatics, which was inspired by Westinghouse and how the air brake worked. But anyway, ended up most things you'd see in the grocery store or Costco or anything like that was on plants that I helped develop or build, and they had that any size that I invented. So after doing that for a while, I was like, I really like space and I want to do stuff in space. And I heard about Colorado School of Mines had space manufacturing and space resources program. So I thought, hey, wait a minute. I was trained in aerospace. I love rockets. Child Joe was going to be a rocket scientist. And now I've spent all this time in manufacturing. I've built mega plants and things that you see on How It's Made. Like, why don't I put these two together and go to mines and transition? And that's exactly what I did. So I was actually installing, or I came to check on some big installs for cores, which is at the bottom of the hill for mines. And I decided to go up there and meet Angel and Chris and all the whole group at the do space resources at mines. And they were awesome. And I decided right then that I was going to go back to school. And that's what I did. I wrote a paper called Lunar that was about expanding or taking lunar regolith, turning into metal, and using it to build megastructures in space. And Angel introduced me to Gary of Cislunar. They'd been established a few years before. And we started writing proposals right away, and we won. So that's how it started. That was around 2020. And now we're approaching 20 people, which is pretty wild. So that's.
So do you see the company's customers primarily as government agencies, private companies, or is it going to be a combination of both?
It's going to be a combination. I think that just like we constantly talk about ecosystems, and it's an ecosystem between government and private as well. So I definitely do. We work with a number of DoD, Space Force type customers, and then we also work with private customers.
Go ahead. No, yeah. What did you start to say?
Well, we can expand on it. It's always interesting because early on, for a lot of early technologies, it is hard to get around the government customer as kind of being a cornerstone customer. But we do see commercial customers, for example, SpaceX with Starlink. That's a very interesting commercial use case. And obviously, we've seen this with OneWeb and other commercial communications businesses in the past. We're always interested in constantly looking for what is that commercial corner tenant that's going to allow us to have platforms for resupply and OTVs that are constantly resupplying things. What is that thing? So we've seen it with communications as a commercial market. Semiconductors is something that a lot of people are researching right now. I've heard a lot. I think that's very interesting about creating the cloud that's actually in the cloud.
Mhm.
And I think some of the new technologies in quantum type technologies, communications, will probably enable that. If there's no latency to actually work between the surface and in space communications, then that could be a real paradigm shift that would shift people's mindsets to, hey, why are we bringing everything back to Earth? Like, what do we need? We need to get energy back here. We need data. We can have our data centers on orbit. We can generate our energy on orbit and beam it back. So eventually, I think that'll be the commercial industries, and who knows what else. I think that's the thing that people need to realize is we always talk about. We're a DARPA Luna 10 performer, and I've had some great conversations with the DARPA guys. Who, by the way, I love those folks. I felt like I was going to Hogwarts when I got off the Uber there and walked in. But we've had a lot of conversations about how Jamestown, for example, this first settlement, that was a coalition of government and private investors that kind of put that on. But they thought that they were going to go get sand and make glass because the sand in Jamestown was awesome. And
Right.
it's not too different than regolith and thinking about all these things. And they didn't end up doing anything with the sand in the glass. It was tobacco and other things that became the big economic commercial driver. So I think we need to keep that in mind, is that it's really hard to know what the true commercial driver is going to be. And I think that's why it's really important for government has been pretty successful in a number of other industries and in space of kind of laying down that spark for us to go over and realize that glass isn't really the thing. So I think that's.
And you've kind of led me very nicely into the kind of crystal ball portion of the program. But I want you to take a minute and just elaborate on Cislunar Industries' vision for humanity's expansion beyond Earth and its role in settling the solar system.
Sure. Well, Cislunar is named Cislunar because we really think about the Earth and the Moon, and we really think beyond that too. So our focus on cislunar space is really because we think that that's kind of the first foundation of helping humankind get beyond Earth and expand into our solar system. The Moon has a lot of great resources. It's a great, and one of the resources is lack of gravity. So using the Moon as a staging ground to get to Mars is a really great concept. So that's really, we are focused on cislunar space right now, but we're also starting to consider what would it look like to build platforms from the Moon out to Mars, and then what does that look like beyond then? There's all kinds of resources between here and just the throughout the asteroid belt. There's I've heard it said that there's 1,000 times more resources than we would easily be able to get on the surface of Earth. So you can obviously drill down miles, but this wouldn't be necessarily what you want to do. So yeah, it's that's the whole idea, is to really kind of build those foundations to allow us to explore and not just explore, but to expand our presence beyond cislunar space.
You've talked a bit about sustainability over the course of the program, and I just want to ask how you anticipate the role sustainability will play in not only your operations, but throughout the industry, with the caveat that the space industry is still trying to define what sustainability means in space.
Well, I also have to, I love sustainability and recycling, and I think that we're all trying to be good stewards of the earth, but I think we're also pretty pragmatic. I spent most of my childhood sorting, recycling and put it in all the special bins, and then realized that I also spent a lot of my adult career making plastic bottles faster and faster. However, I also like to bring up to everybody that my company helped, and some of the things I invented helped allow lightweighting of plastic bottles and aluminum products up to. There's some plots, but I think plastic bottles for water now look like plastic bags practically. So interestingly enough, the industry allowed itself to reduce its plastic, at least per bottle, I think more than 50% over the course of a decade or something. Now, this was driven by economics. It's less plastic's cheaper. So that's why they did it. But interesting enough, I always like to kind of, it's fascinating to me that that's done more. We realized that recycling wasn't actually that viable, unfortunately, for many reasons. On the earth for plastics. And so so I think we really, there's a lot of perceptions that we need to shift here. And in space, it's not like here. You can't get a bunch of folks together and say, oh yeah, well, we'll pretend, theoretically you could recycle it, but realistically it's not economical, but it doesn't really matter because, we'll figure that out later. If we do this in space, we're not going to be able to have access to orbits because there's going to be a bunch of garbage there. So really, sustainability and recycling isn't really an option. It's not a nice to have, or it's not a should requirement. It's we have to, we must, because otherwise we'll get creamed by it and it'll keep us from operating there. So then also it's just an obvious thing to do. We analyzed the material in a starship, for example, right, on the lunar surface. Now, I mean, a starship, the best way to reuse a starship is to use it as a propellant tank. So that's one obvious thing is not to, when we talk about recycling or reusing, I mean, a lot of times we're talking about just reusing something, repurposing. Sure. But also when we get further into it, I mean, there's a lot of landers that land and fall over, and there's a lot of other spacecraft that are very old and or upper stages. They're just really nice stockpiles of materials. So the ConOps to actually take those and reuse those materials become much easier and much more cost effective. And so it becomes a necessity that will drive these operations, I believe.
Joe, we're just about out of time, but we do ask this last question of all of our guests, and that's to look out, if you might, over the next 10 to 15 years in space commerce and your role in it, and tell me what you see.
Well, I spent a lot of time in industry in the past, and I like to say that Cislunar kind of sees itself as a vertical disintegrator. A lot of space companies are very vertically integrated, and that's great. When I mean, the space industry is very much a craft industry. It's in many ways it's way smaller than the craft industry. I joke with many friends that we literally are all sort of craft brewers, and we're stirring our beer, and some of the very wise monks in the Class A industry have very special paddles. But I think we're all starting to realize that as we scale, you don't necessarily need the special paddle and the special tank to make these things, and in fact, we can make them a lot better when we start scaling these operations and thinking about these in an industrial manufacturing way. So that's really, a lot of us at Cislunar come from industrial manufacturing. If you've ever been to a SpaceX plant versus some of the other places that make some of the other established space companies, there's some big paradigm shifts happening right now. And that's not a knock on old space. It's just that now there's, we used to make satellites 10 at a time. So of course it was the craft industry. Now we're starting to make, SpaceX is making 1,000 at a time. Kuiper's making 1,000 at a time. So this is really going to shift things. And in my industry, iPhones are, do you know how fast iPhones are made? This is a great metric.
I have no idea, but tell me.
iPhones are made at 300 a minute. So when we think about that, there's a lot of folks who are like, oh, space is going to get cheap once we have economies of scale. Like we need to do space like iPhones are made. And it's like, okay, well, we need to make 300 a minute. Obviously, we're not going to make 300 a minute right now. Right. But there are things that we can make for space that we might be able to start making at economy scale. So we all need to think about it that way. And that's why I joke about, say vertical disintegration somewhat jokingly, but actually quite realistically, if we have 100 different rocket companies that are all vertically integrated, well, that's 100 different individual parts. Versus if there was one supplier selling the same parts, that's 100 of the same part to 100 different rocket suppliers. And now you're starting to get economies of scale where you could actually drastically shift pricing and get to the economics that we need to make this all happen. So anyway, I see us as when you go into plants, I think you'll see a lot of Cislunar Industries hardware, and I think you'll see a lot of services offered by Cislunar. And then I don't know if it'll be 10 years or it really depends on how passionate people are for these things. But I would love to see Cislunar providing some of the first materials that were sourced from space. In space. And so, materials when, where, and when you need them is really what we'd like to offer within, the decade or so.
Joe, we are out of time. It's been a really interesting conversation. Thank you so much for joining me today.
All right. Appreciate it. Thank you so much.
Joe Pawelski is the CTO of Cislunar Industries. And that's going to do it for this edition of the Ex Terra Podcast. You can subscribe to the audio version of the podcast on Spotify, Apple Podcasts, Audible, and many other popular podcasting platforms. Be sure to click subscribe so you don't miss any of our podcasts or any of our other videos. You can get daily updates on space commerce by subscribing to the Journal of Space Commerce on Substack at www.xterrajsc.com. And one thing more, be sure to connect with us on LinkedIn and follow us on X at XTerraJSC. Until next time, I'm Tom Patton. Thanks for joining us.
I wanna go faster, faster. Hands in the air, we're gonna crash. Searching for the answers. My Galileo, the proof is looking glass. Thirst for reason. Our dreamer's eyes we gaze into a sense of purpose, know my view. Like finding water on the moon.